Hello and welcome everyone to the world of Hack the Mountain 3.0 and this informative live session. I am Shubhangi Bhardwaj. On behalf of the entire team of HTM, would like to extend my regards and welcome you all to this community-based hackathon where we regularly conduct webinars, workshops, HTM Qubits sessions like this one. All of this to strengthen your skills and help you perform better in the upcoming hackathon. Today, we all have gathered here for a very informative live session by Miss Abigail Castro. She's a developer evangelist for Hedera at Swirlds Labs. This session will be on building scalable Web3 applications on Hedera. Now, without any further delay, I would like to call our esteemed guest, Miss Abigail Castro, to take over.
Hi, thank you. Thank you so much. I'm really glad I can be here. Apologies for having to have everyone start a little bit late. I really appreciate everyone being here and taking the time to being part of this hackathon. Hackathons are very exciting, and it's something that I always loved doing when I was in school or even just out of school, just joining hackathons. I'm going to go ahead and share my screen so we can get started. I'm going to play from start. And yeah, a little bit about me. My name is Abby Castro. As was mentioned before, a fun fact about me, which I like to start with, is that I have 4 dogs, which I will quickly introduce. This is Charlie, Nori, Luna, and Snuffles. Just want to make sure everyone can see my screen. Is that right? Okay. Okay, perfect. The title for today's workshop is Build Scalable Web3 Applications on Hedera. We're going to start by doing a quick overview of Hedera, learning more about some of the network services that Hedera offers, then dive into a technical workshop so it's not just all me talking and it's all PowerPointy. We will be doing some technical portion, and then we'll go into some resources and where you could learn more. But before we dive into Hedera, I'd like to take a step back and sort of take a look at how the web has evolved to understand Web3 and then lead us into Hedera. So, for thousands of years, pre 1970s, everything was tracked on paper. Transactions, business transactions, hospital records, they were all on paper in a file cabinet, and it wasn't very efficient. As technology got better, we entered the digital era in the 1970s, where mainframes and computers ended up being more common and we were able to gain speed. Computers were able to manage data a lot more efficiently and they were even able to automate tasks. During this time, a lot of this information, though, wasn't accessible. So in the early 2000s, when we entered the internet era, we got interconnected computers, which allowed us to collaborate with people around the world. We were able to gain access and collaboration along with the speed that we had gained previously. This was the Web 1.0 that we mostly remember, where most of the consumers were consuming static websites, so static images and text. And the people who were producing these were software engineers or software developers that had studied that during the time. As technology continued to evolve, we ended up going into Web 2.0, still within this internet era. This allowed more mobility, more social interactions, and it also opened it up for non developers to be able to contribute to the web. But with this came some valid concerns about privacy and our data. And this is where in 2009 we entered the trust era, which is one of the reasons where Web3 is going, is to solve some of these problems with privacy and data and access control. We want trust. And so this evolution of the web is important to us because it's a technology that impacts everything that we do and everything that we will continue to be doing in the future. So at the core of this evolution is our distributed ledger technologies, which is what I want to talk about next. So distributed ledgers are a key component of Web3 because of their qualities. These are peer-to-peer networks where multiple members, or you could call them nodes, maintain their own identical copy of a shared ledger. And you can see in this image here that the entire network has to verifies and executes all of these records and each transaction to all of the participants in the network. So it gets everything, shares the data very quickly. In contrast with this image on a centralized ledger, you get it requires a central authority to be able to update and communicate the records to the participants in the network. And one of these key differences from this distributed ledger and a public or a traditional digital ledger is that the DLTs operate independently of a central authority, and they're automatically mirrored so it shares the information quickly. So now that you know those key differences, some of the qualities of a DLT is that there's no central point of failure. They're reliant on strong cryptography, so they don't have to, they're tamper resistant. On top of that, a participant doesn't need to trust any other participant to guarantee that it is a valid ledger. So it creates a trustless system. Most DLTs have the same three building blocks. There's the ledger itself, there's a consensus algorithm, and there's an incentive or reward for the network participants, which lately those rewards have been in the form of cryptocurrency. The governing structure and the consensus mechanism act as the rules for updating the ledger. So what does this all have to do with Hedera? Well, Hedera is a third generation public distributed ledger, and it provides 10,000 transactions per second at a fraction of a cost and with a final consensus confirmation of 3 to 5 seconds. It's come a long way from the first and second generation networks. But what about comparing Hedera to other third generation networks? Well, that's where this one comes in. You can see that this is a comparison of third generation DLTs, and the clear differentiators are the transactions per second, the fixed transaction fees in USD, and the transaction confirmation time. But the one that always gets me is just how energy efficient Hedera is. So UCL Center of Blockchain Technologies generated a report of various different networks that they studied, and data has shown that as more transactions occur on the Hedera network, the lower the energy consumption. And this is all possible due to the algorithm that powers the Hedera network. This algorithm is called the hash graph. Beneath the hash graph surface is a different structure that solves the same problems as traditional blockchains. Bringing our attention to the blockchains, and what we know is that they naturally result in high energy usage. They work off of a good enough probability and not a guaranteed consensus, and to some degree inefficient due to having to prune stale blocks, on top of being slow, but for security reasons. On the other hand, the hash graph is an open source consensus algorithm and data structure. It uses a directed acyclic graph, also known as a DAG, and internally uses gossip about gossip protocol and virtual voting. This is what allows a network to have a carbon negative infrastructure. And it is the heart of the technology that enables the high throughput, allows us to be the most sustainable, and reduces cost drastically compared to the first and second generation networks. Instead of having to prune the growth, you weave everything back into the body of the ledger. So going into an overview of the Hedera network, at the core is the hashgraph consensus algorithm, which we just briefly touched upon. And next we have our services. There's a consensus service, a token service, and our EVM compatible smart contract service. We then have a governing council that is a group of organizations and top universities that help make decisions for the network. It brings decentralization, transparency, and trust. On top of this foundation is where we have applications that are built for process integrity, identity, tokenization, payments, and a lot more. Diving a little deeper into the Hedera Governing Council, we currently have up to 39 leading global organizations from various industries, universities, and across different markets. Each member is required to run a network node, and they're diversified through time, meaning that they can serve a 3-year maximum term with up to 2 consecutive terms. Once that organization's term is up, it is their responsibility to find another organization that will take that seat. This ensures that as organizations' time is up, we don't end up with a bunch of empty seats. On top of that, they each have an equal influence of 1 vote. It's important to note that there are also different levels of decentralization within distributed ledger technologies. And that leads us to this quadrant. In one dimension, they can be permissioned or permissionless. And in another dimension, they can be public or private. Any combination of the two, and we end up with this quadrant. So public permissionless are highly decentralized. And in today's world, these are the networks like Bitcoin and Ethereum. Public means that anyone can build applications on the network, and permissionless means that anyone can run a network node. They're also public and permissioned, and that's where Hedera falls. Anyone can build applications on the network, but the nodes that constitute the network have to be invited to join. In private and permission networks, then permissionless, this means that the nodes can join freely and anonymously, and that's the permissionless part. But the applications that are deployed in production have to be invited, and that's the private aspect of a private permissionless one. Finally, the private and permissioned is the least decentralized because the applications and the networks both have to be invited, and you have to provide a form of identification. As a reminder, Hedera is currently public permissioned, so anyone can deploy applications. However, the network nodes do have to be known and invited. We're on the path to becoming public permissionless, and this is our phase 1, starts with the governing council, which you can see is on every continent except Antarctica. And phase 2 opens it up to community nodes. This is exciting because a couple of weeks ago, we introduced staking, which is allowing the community to contribute to consensus, which will open up even more once community nodes or permission nodes come online. Phase 3 introduces permissionless nodes, or anonymous, and this represents the network in its most decentralized state. The network continues to grow in use cases with over 14,000 developers attending global hackathons, meetups, and being active in Discord. There have been over 1 million total accounts on mainnet, and there have been a good variety of use cases that come from individuals and smaller teams. There are more than 100 applications in production on Hedera mainnet since open access on September 2019. Let's dive into some of these network services that developers use in order to create use cases. We're going to go into the consensus service, the token service, and our smart contract service. These network services are available through our SDKs in the following languages: Java, JavaScript, Go, and there's an awesome community who have authored a .NET SDK as well. A consensus service is a topic-based publish-subscribe API. It allows you to record audible and immutable event data. It has topic management, so applications can subscribe to certain topics to receive messages that they truly need. And the consensus order has an audible log of history that is tamper-proof and provides this by tying messages together. Advertisement businesses has a lot of intermediaries like middlemen and fraud in the industry. A lot of businesses are charged a lot of money for ads that haven't really been seen by anybody. AdStacks is providing verification of events of viewing of these advertisements by leveraging Hedera's consensus service without the high cost. This is bringing data integrity in advertising. In addition, processing and storage is kept outside of the network to allow for higher speeds and scalability. You also have a choice. You could either keep everything, keep nothing, or just anything in between. The Coupon Bureau has seen a decline in the use of coupons due to the lack of standardization and the susceptibility to fraud. The consensus service increases traceability by tracking the life cycle of a coupon from creation to redemption. This raises the transparency and the trust, and the high speed allows for a consistent view of data and real-time authentication to remove the redemption of fraud offers. Moving on to the token service. The token service makes it easy to issue native tokens at a low predictable cost, with scalable performance and configurability. You can have scalability of tokens up to 10,000 transactions per second, only costing you 1 USD in each bar to create a token type. EFTPOS is a household name in Australia. They process a large amount of card payments, and they're having a challenge with the technology gap to support micropayments. Their solution has been to leverage the Hedera consensus service and the token service to enable secure and affordable micropayments on the web for their users. Our smart contract service. So smart contracts are essentially self-executing contracts. They provide a lot of versatility. They create independence by removing the intermediaries, and they enable trustless transactions. On Hedera, you can run smart contracts that were written in Solidity, and they're executed in order received, and there's no need to ever pay extra to be included earlier in the history. There's also a choice to provide admin keys that will allow owners to make alterations to the contract. Smart contracts are EVM compatible with fast performance of 15 million gas per second and costing you 1 USD in each bar to deploy. In addition, it has a very low carbon footprint. So why build on Hedera? Well, a lot of the problems that Layer 1 blockchain-based technologies face is that they have an enormous amount of energy, which can make it difficult for someone who has personal environmental goals. It could have low processing speeds, which makes your application less likely to be popular since users will not be having a very good experience using your application. High unpredictable processing costs make it difficult to know how much profit you're making, if you're going to be able to run the next month, the next 2 months, and that just doesn't seem very feasible. Security vulnerabilities, along with centralization and a lack of transparency. Hedera services guarantee that you will build applications with a high throughput, fair ordering, and low latency consensus, along with a very low carbon footprint. So, how can you start developing on Hedera? Well, the first step is to get a testnet account. You could follow this QR code or go to portal.hedera.com/register, and here you will be able to sign up for a testnet account that receives 10,000 test HBAR every 24 hours, which gives you plenty of HBAR to be able to develop and test on the test network. For the next portion, I will be going through a coding example, which I would love for people to go along with me. And in order to do this, it would require getting a testnet account. So I highly suggest just going on there quickly and getting a testnet account. If it takes a little bit too long to receive the actual credentials for the testnet account, then you can simply watch and follow along with me. And then once we are done with this presentation, you will have the option to get a copy of the slides, and you'll have a link to the example as well. So I'm going to give everyone about a minute or two to register if they'd like while I continue and I switch from my PowerPoint view to my coding view. I will also set a link because this will be on an online editor. So let me go ahead and do that really quickly. Let's see. Share. Okay. So here's the link. All right, so I have sent the chat, the link in the private chat just now. We are going to be creating a fungible token. It's called the fungible token creator example. And I will change my screen to be sharing my actual Chrome. So let me share. Let's see, this one. There we go. So you guys should all have started on the EVM example. You may have my operator account ID and private key, which is completely fine because this is for educational purposes and it is okay to share your private key just for this case. You should never share your private key, however. and let me get started. Let's see. There goes that. Perfect. Okay, so this is Code Sandbox. This is an online editor. This is what I tend to use when wanting to create online workshops. What this offers is files over on the left-hand side. You have the ability to add dependencies on the bottom, and then you have a terminal over here on the right. As if you look over to the dependencies, you can see that I've added the Hashgraph SDK. Since this is a JavaScript project, or a Node project, I added the JavaScript SDK and .env, which is a dependency that helps us pull environment variables out of our .env file. So to begin with, we have our operator account ID and our operator private key and our environment variable, an environment file. When you created a testnet account, you received an account ID, a public key, and the corresponding private key. This example is going to require your operator account ID to be your Hedera account. So I'm going to go ahead and copy my account ID on there. You may already have it, and if you do, then that's fine. Something I also wanted to mention quickly, if you want to follow along, it might ask you to create an account, and you can go ahead and do that. You can connect it to your GitHub account if you'd like, or you could sign up with your email. You will then be able to actually work through this example with me. We're then going to grab our private key that corresponds to that account. A friendly reminder, never ever share your private key because that is the easiest way to lose access to your account, and that does not sound very fun. It would be a very sad day. I am sharing it because this is a test account and I'm not using it for anything other than for this workshop. So now that we have our operator account ID defined and our operator private key, we could head on over to index.js over here on the left to look at the example. I'm going to clasp the fungible token example so we could focus on a certain section of this file first. So for this example, we are going to be leveraging the Hedera token service in order to be able to create a fungible token type and then mint these tokens. In order to do that, we need to define our client. Our client comes up from our account ID and our private key, and it's going to be used to execute transactions. When I say execute transactions, I mean submitting them to the Hedera network. So the way we create our client is we first use the account ID class, and we pull the operator account ID from our environment variable file, and we create an operator account ID, which will be of type account ID. We then do the same thing for private key, but rather than using the account ID class, we use private key, and we generate our operator private key, which is of type private key. We then use client and call for testnet, which means that we're creating a client specifically for the test network, and we're setting our operator account, also known as our client, to our operator account ID and our operator private key to get back our actual client. So now that we've set up our client, we could get started. Since we're going to be minting a token, it is important that we generate a supply key. This supply key is in charge of authorizing these token mints. If we don't have a supply key, then we're not going to be able to mint. The way we generate the supply key is simply by calling generate ed25519, which is the type of private key that we're generating, and we are calling it supply key. After we have done this, we could go into our fungible token example. So I'm going to go ahead and open this. You can see that it takes in that supply key. The first step is to create a treasury account. That's lines 21 to 28. That the whole chunk just kind of lets you know we're going to create a treasury account. This account is going to be the holder of the collection of the token. We call it a treasury account, but it's just a regular account, which we're calling treasury account. I created a helper function called create account, and we're not going to go into it, but it just essentially creates a account create transaction and then executes it. What we're giving it is the client in order to execute it, and we're giving it a number which represents the initial balance. This create account is going to be created with an initial balance of 50 HBAR. This HBAR is going to be paid from your client. So that's why it's important that your client has enough HBAR to, one, be able to pay for the execution of the transaction, and two, to pay for the initial balance that you're giving this new account that you're creating. Once we create our account, the information that's important that we hold is our treasury account ID and our treasury account private key. And then we print it out and we say our treasury account ID is this, and this is our private key, which we will save locally or in a password manager. We'll save it somewhere safely. After we create our treasury account, we can go and actually start creating our token type. On line 32, you can see that we're calling create token. We're giving it a client. We're giving it a treasury account ID, the supply key, and the treasury account private key. Let's head on over to createToken.js, which is over here on the left, and you'll see that this function is not fully complete. It actually has some errors, and this is the actual interactive part where I will code, and you could code along with me on creating a token. So the first step on creating a token is building the transaction, and we could do this by saying const create token transaction. We'll instantiate a new token create transaction. We'll set the token name to be popsicle because it's been really hot over here where I am. So we'll call this popsicle coin. We'll then set the token symbol to pop. I like to think of the symbol, or the symbol is like Ethereum has ETH and Solana has Sol. These are all publicly available symbols and names. We then set our treasury account ID to the one that we passed in, since it is the one in charge of holding this collection. And we set our initial supply to 0, meaning that when this transaction executes successfully, this treasury account will have an initial supply of 0. Next, we set the supply key. And what we're doing here is, once we're ready to actually mint the tokens, this is the supply key that we are expecting in order to change the supply of the coin. So this is just sort of saying, hey, heads up, this is another level of security. If you don't have the supply key, there's no minting that's happening. We then set the max transaction fee to be 30. And what this says is that we are willing to pay to 30 HBAR for the transaction to go through. We know that at this time, a transaction costs a fraction of a cent, so it will not take the full 30. It will only take exactly what is necessary. There's no like refund process. It only takes what is necessary. This is just you making sure that you set a max. We then freeze with our client, meaning that we're freezing the transaction from any further modifications. And what we've done here is we've built a transaction for token create. The next step is to actually sign the transaction. And we're going to await this because it returns a promise. And we're signing it with our treasury account private key, because this is us actually associating the treasury account with this token. Once we've signed our transaction, it's time to submit that transaction to the Hedera network. And we do that by calling execute. So when we call execute, we get a transaction response. We also await this because it returns a promise. So we say create token signed, execute. We're going to execute this with our client. And this is the way we execute. After we execute, it's always nice to have a receipt. So we're going to grab the transaction receipt from the transaction response. And the receipt holds important information like the transaction status, and the token ID, which we will need in order to mint. Once we do that, you could see that we created our token transaction, we signed it, we submitted it to the network, we then requested a receipt, grabbed the status and the token ID, and this will let us know whether the token type creation was a success or a fail, and what token ID it has. So we'll go ahead and save that and head on over to index.js. So just a small recap, we've created our treasury account. We've written the code to create a token type. And the next step is to make sure we have the code for actually minting the token. Step 3, line 40, awaits mint token. It's given the client to make sure we execute the transaction. It's given the token ID of the tokens we're going to mint. We want to mint 100 of them. And of course, we can't forget the supply key, which will be authorizing the mint. Heading over to minttoken.js, we could see that the first step is similar to the when we were creating a token. It's to build the token mint transaction. So we end up calling calling it mint token transaction, and we instantiate a new token mint transaction. We set the token ID to the token ID we passed in. We set the amount to the amount we passed in, which was 100, if we remember, and then we freeze with our client. This one was a lot smaller. You could do a lot more with both, but for this example, we're keeping it pretty simple. We're just setting the token ID, the amount, and then freezing it. We then have to make sure we sign this. Not schedule, we'll do sign. And we sign this with the supply key because when we created the token, we told it this is the supply key we expect in order to change the supply. So that's what we're doing. And then we will execute this, get the token response. Execute this with our client. And then make sure we get the receipt. We then make sure we get the status of this. Like that. So we have created our transaction, we've signed it, we're executing it, we're getting the receipt, and then we're making sure that we get the status so we can print that out to see if it was a success or a fail. So we could go ahead and save that. The way Code Sandbox runs its code is this terminal is read-only. So you will have to go to this plus sign and open up a new terminal. This new terminal is now ready, and we call node index.js. And let's see if this runs on the first time. You know, code sometimes has bugs here and there. Look at that. So we're creating our treasury account with this ID. We have our private key that was printed out, and we should save and keep safe, never share. We have created our token type. It was a success, and it was created with this token ID, and minting the token was a success. Rather than just stopping here, I'd like to go a step further and actually show you importing it into the wallet. So I will go ahead and set that up so you guys could see that actual coin in the wallet. And I will also send the link in the chat. So in order to import this treasury account, you could go to wallet.hashpack.app and you can choose to import by private key. So I'm going to go ahead and sign in. And let me actually, okay, perfect. Let me share my screen so you can actually see. Stop share. Perfect. So when you go to Hashpack, you'll see that it's asking you to create a main password. I'm going to go ahead and create one. Rather than creating a new wallet, we are going to be importing our wallet. And we're going to be importing an existing wallet, and we're going to import using the private key. Let me make sure I have this open. So the account ID is something that it asks for first. And I want to actually send it to you guys so you guys can go ahead and do it, even if you didn't go through the example. This is the account ID that you will be pasting. It's going to say that the account does not exist. However, all you have to do is check testnet account. The account is a test account, therefore it doesn't exist on the mainnet, and it gives you a caution to make sure you understand you're making a testnet and to not send any real HBAR to this account. After you click OK, that message goes away and you are able to enter your private key. So the private key, something that you should never do is share it. The treasury account's private key will be shared in the chat. Once that has been pasted in, you can go ahead and click next. I like to give my wallets nicknames, so I will just say Hedera token service, fungible example, and then create wallet. And you will see that our popsicle coin is in our wallet. There's 100 of them, and if you click on it, you can see that the token symbol that we set in the code is here, set to pop. Here's our token ID. We are of type fungible, and a couple of other things like the token supply type, the initial supply, which we had set to 0, some decimals, the treasury account ID, and a couple of other things that we didn't cover, but that you can do when creating a token. And then we have our supply key as well. So this was an example of creating a token, a fungible token, minting the token using the Hedera token service, and then importing it into our Hashpack wallet and being able to actually see our coin in there as well. If you guys have any questions, I will hold them off for just 1 to 2 minutes. I want to share some of the resources that you can use if you have any questions when working with Hedera. I should have said play from current. There it is. So for documentation, you can head on over to hedera.com/get-started. That's our Get Started guide, which could lead you to our documentation, which is at docs.hedera.com/guides. We have coding tutorials through articles or videos on our YouTube, as well as a developer Discord where you have the opportunity to talk to different developers from all over the world working on various different projects, looking for help, or just looking to collaborate with other developers who are building on the network. If you would like to get a copy of these slides, I highly encourage you to follow this QR code. It will just ask you 2 to 3 questions that you will submit. You will then get an email with a PDF copy of these slides, which will have the name of the fungible token example, which you could follow on your own. It's also available on GitHub if you'd later like to fork and just build off of that as well. Now I'm opening it up for questions. If you have any questions, just let me know. Thank you. I think I see some right here. So I see why choose Hedera over other networks. I hope this presentation sort of answered some of that. We have fixed fees, very low predictable fees, on top of being very easy to work with our SDKs in various languages. I see hack the
Yeah,
mountain. Yes.
yeah, I think we got pretty some questions from
Yeah.
the comment sections as well as like we have got some questions over our community. Like we had a poll in a community and people asked some questions, so we had some hot questions for you as well. So let's start with this comment section first. So we have this question with Monica, which says, "What are the prerequisites that are required to learn and build on Hedera?"
Okay, so the first step I would say is finding the language that you're comfortable in. And if that's JavaScript, then starting with the JavaScript SDK. If it's Java, then starting with the Java SDK. I think if you have any programming language, a lot of it can port over to some of these, even if you don't really know that language. A lot of those core concepts still port over. So as long as you have a technical background, and you are comfortable programming, then this is what I would say are some of the prerequisites to actually build and learn on Hedera.
Definitely, that's great. And we would also link some resources like which are documentations which are available on Hedera, so you guys can like build on it.
Mhm.
So we have this next question from Neha. Like, what are the network services which we can use to build project in Hack the Mountains?
Yes, so you could use the Hedera Consensus Service, which is the topic-based publish subscribe API. What you do is you create a topic, and then you send messages, and you can subscribe to those messages, and that way your application only gets the information that it really wants. That's the consensus service. The second service would be the Hedera token service, which we would quickly went through. You can use it to create a token, non-fungible or fungible. I went the fungible route, and you could then mint your tokens. We then have our smart contract service, which is EVM compatible. You can write these contracts in Solidity, and you could actually run them. And there are some great resources online that show you how to deploy these smart contracts, and it only costs you about 1 USD in HBAR to do that as well. So those are the three main services.
I'm so sorry. My net got disconnected. I would like to continue with the questions. And actually,
Okay,
before
that's
continuing with the questions, I would actually hello. You were
yeah.
saying something?
I didn't say anything.
Hello.
Hi, can you hear me?
Okay. Okay. Yeah. Now I can. Okay, so firstly, actually, I heard all of your session, and the last moment my Wi-Fi got down, and I'm sure all of the audience, I mean, all of the viewers, we got to learn a lot, and I just wanted to add that because it was such an informative session. Now coming back to the questions, um, since we have a lot of questions on the comment section as well as on our community platform. Next question I am taking from Vikas Kumar Yadav. Is this only for the token? Whatever you portrayed, is this only for the token?
Would that question be able to be elaborated? What is this in the question?
I Okay, I think we should leave that question because even I don't know what that person means to say. We can take next question from Puneet. Why to choose Hedera over other networks?
Yeah. So one of the main reasons why choosing Hedera over other networks would be beneficial for you is the carbon negative if you have personal environmental goals or if your team has environmental goals. Another one is those low predictable costs and the fixed fees, meaning that there won't be any variables and you'll actually be able to know what your profit is or if you're capable of continuing your project over time. We're also EVM compatible with smart contracts. Therefore, you could run Solidity written contracts, which makes the portability a lot easier if you're coming, let's say, from Ethereum.
Okay.
Mm-hmm.
Okay, so the next question is, does Hedera help startup who want to build on Hedera during hackathon? What type of support can we expect?
For porting over from where? Could you repeat the question? Sorry.
Okay, I'll repeat the question. Does Hedera help startups who want to build on Hedera during hackathon? What type of support can we expect?
Oh, so there's various types of support. If you were to be part of the Hedera Discord, there are different channels in there that correspond to different services. So let's say you have a smart contract question. There's a smart contract channel where you could post your question, and there are various people from Hedera who will be there who could help you sort of get unstuck or point you in the right direction. There are also other developers in there that can help you. So there's that level of support. There's also another level of support through the foundation where if your startup has a like a pitch or a really great idea, it is possible to get the foundation to help with that as well. And I can connect with you after if you'd like and connect you to the right people with talking to the HBAR Foundation. So those are the two different levels.
Okay, so we can have the next question, which is, what are future plans of Hedera in the field of Web3?
You cut off. I heard what are the plans for the future of Hedera, and then that was it.
Yeah, so I think there's some issues from Shivangi's side. So let me take it. So the question is, like we had some community questions going on. So the question was like, what are the future plans of Hedera in the field of Web3 and blockchain?
In the field of Ethereum, and what was that?
It's a blockchain.
Oh, and oh, with Ethereum.
Yeah,
Um, so what are the plans for the future of Hedera? With I think the plans is just still continuing to make sure that we're growing adoption within the network, and we're continuing to release features that are going to help developers be able to adopt and build on the network. That's what I would say is the general direction.
I think that's really great to hear. And
Mm.
we have this next question like, can you list down some resources to build on Hedera in the Hack the Mountain track, the track from Hedera, which we have got? So, can you list down some resources for these guys, if they want to build on the track?
Yes, I could also change my slide to here. Um, there are some resources I could link, like specific articles and videos that you'd like me to link them on the Discord. Is that right?
Definitely, definitely. Yeah, that
Yeah,
works.
I can definitely drop those links in there as well.
Cool. So the next question we have got is like, how is the power saved on Hedera? The slides which you talked about in the starting.
I don't think I'm understanding the question. How is the power saved?
Like you talked about how Hedera is, power consumption. It saves a lot of power consumption than the other blockchain apps. So the question was, how does it saves? Like, how exactly does it algorithm works on the back end?
Oh, okay, so that has to do with the algorithm, which can get pretty deep into the weaves with it. So the way the hash graph consensus work, since we don't have to prune any blocks and everything's getting weaved into the ledger, the way the gossip protocol and virtual voting works just makes it more efficient. I can drop a link because there's a very, very interesting video that Lehman, the creator of the hash graph, goes into the mathematical concepts of how this data structure works. And due to that, there's a lot of energy consumption due to not having to prune those blocks, due to not having to have miners and be constantly consuming this energy. I think it's a very interesting video, and I will make sure to link it for anybody who is interested in the math and how the algorithm works.
Great, great. That's really great to hear. So we got a next question is how compatible is Hedera with other networks?
Okay, so in terms of smart contracts, which is the way that I hear a lot of people interested in how compatible Hedera is, we are smart contract, are EVM compatible, meaning that, for example, another network that may rely you to learn their new smart contract service or language, you don't have to do that with Hedera. You can just bring your Solidity contracts and you can convert them into bytecode and deploy them onto the Hedera network. So in that aspect, Hedera is compatible. We have the token service, which other networks have token services. So if you're coming from another network, you'll see that there are some correlations with some of the services. The difference can be on just the way you build these transactions, the way they execute, kind of like the nitty gritty of how you're writing the code. But I would say that in that sense, Hedera is pretty compatible.
Great, great. I think that's give the answer to that question. So we have a next question is like it's quite a technical one. So how is the third party cryptocurrency wallet supports Hedera?
How does the third party crypto? Sorry, I
Yeah,
lost it.
cryptocurrency wallet providers support Hedera.
How did it support Hedera? I don't think I actually know that answer. Um, if you'd like to send that question to me, I can make sure I get the correct answer
Sure, sure,
and relay
definitely.
it back. Yeah.
And we got an like a couple of more questions. Like one is how is privacy maintained in Hedera? Like how do you guys maintain the privacy of a account?
The privacy of the account.
Yeah.
Um, I think I would need a little bit more information on what they mean by that. Like a more directed question would be great.
Sure, sure. And one question from one more, like it's quite a general question, I would say, but it's like how to be a developer evangelist at Hedera.
Oh, how do you become a developer evangelist for Hedera?
Yeah, yeah,
Um, I would say that if you have the passion to speak to developers, to learn about their pain points, and actually like being part of the community, the number one way to start is contributing to open source projects, um, building, going to meetups or hackathons, and finding a way to connect with other developers. And then if there's a job that opens up, definitely look on the job board and you could apply and let that your skills match, meaning that you're for the developers, you're for the community. You want to make sure there are good workshops out there, good tutorials out there, and you want to make sure that the developer's experience working with the product is positive. So as long as you have all those intentions, you will build those skills, which will make you a good candidate to become a developer evangelist.
great. I think that answers the question.
Mhm.
We got another question is like how would be the judging of this track in the Hack the Mountain be done? Like, if you could give some insights about it.
Yes, for judging, um, I would say that as long as you follow the requirements that Hack Mountain is requiring for submissions, then and you have Hedera with a good. Okay, so let me restart. I would say when you are presenting your product or your project, it's good to have a good technical portion of it, but it's also great to have a good story. Make sure you define what problem you are solving early on so that the person who's judging it actually can get on the same page with you and say, okay, this is the problem they're solving. This is why they chose Hedera and why they're solving it this way. And that will give you a good opportunity to make sure that the judges understand why you're doing what you're doing, why it matters, and make sure that you could win.
Yeah, definitely. I think that is something they give it gives you just of an idea about exactly what they need to build and how the judging would be done. So
Mhm.
my last question, without taking you so much of time, Abigail, so I would ask you, like, people have asked a lot about like what are the prerequisites? Is there any prerequisites they need to know? Like, they want to build on Hedera, they want to solve the track problem. Is there any prerequisites they need to know? Like, is there any JavaScript or anything that is required for them to learn before?
No, so definitely just get a testnet account. From that testnet account, choose the SDK that you with the language that you're most comfortable, Java, JavaScript, Go, or the .NET one, and then follow any of the tutorials that I will link on Discord or that are in this articles, like how to mint an NFT token, how to deploy a smart contract, and as long as you know that language of the SDK that you chose, everything else will just come as you're going through tutorials or as you're speaking to other developers. I'd say just dive in and just continue building, continue trying. And if you have any questions or any problems, make sure to reach out on Discord.
Yeah. Thank you so much, Abigail.
Mhm.
I think that's it from my side. We have got plenty more questions, but I would love, to come to over to Discord and, solve people queries there. That would
Yeah.
be more interactive to them. And with this, I would like to thanks Abigail for your time and everyone who was watching the live and you were asking some questions. And I hope everyone gets benefit from this workshop. And yeah, I would be ending this live. Thank you so much, everyone.
Right. Thank you.